All right, so we're back for the second video of our distance learning journey together in the world of geometry. I hope you're all doing well. Um, so this video should be up on Thursday, I hope. And Friday, I'm going to try to live stream the lesson. So be on the lookout on Google Classroom for that if you would like to join that. You can ask questions and actually interact with me. And I'm going to record this anyway. Anywho, so first lesson that we talked about were different parts of circles, things that you've seen in the past, but also things that you might not have remembered, like arcs and chords and so on and so forth. So this lesson is going to be how can we find the measure of arcs, whatever that means. And the learning objective for today is, well, we'll be able to explain the differences between the measure and the length of an arc. And we're also going to be able to describe the relationship between central and inscribed angles. Now, this is kind of a two-day-ish lesson, so I'm going to point out one quick thing. This part of the learning objective and this one is going to be saved for a later date. That's probably going to be what we're going to talk about on Friday, because it really kind of puts everything that we learned together. So let's just hop into it. So the first thing I want to do is kind of recap a couple of really key important things before we move on. A circle is created by the following. Let me show you how this works. Let's say I have a point, right? Every circle has a center. You can call it whatever you want. Typically, you'll see it as center C or center O. I'm going to call it O for today, okay? And the way that it works is you pick another point. So let's say from here to here, right? This distance away. So I want to find all the other points that are this distant away from point O. So the way that we do this, and unfortunately we can't do this yet, but this is actually something that we're going to wind up doing in the future, is using something called a compass. And we are going to learn how to create things, let's say, in geometry. But anyways, so what this thing does is, you probably have used this before, and you can kind of, what's the word, make circles. So you see how this tool is measuring the distance between O and this new point. If I now trace around like this, every single piece of purple that you see is that same distance away. And you should hopefully recognize that that distance between O and that new point is our radius. But my question is, and I'm going to erase this and ask one more thing, right? I'm going to retrace this. How far am I going around this circle? So, for example, if I were to ask, what's the angle measurement of a circle, right? How many degrees do we need to go around to get back to the beginning? Hopefully you're saying 360. So the degree measure of a circle, just as a reminder, is 360 degrees, right? So the degree measure of a circle is 360 degrees, okay? We've definitely talked about this in the past, but this is such an important point to bring up. Because what does it mean for a degree measure, right? We're talking about going around in a full circle. So let me ask you another question. I'm going to do this a little bit differently. So I'm going to erase a couple of things. So I really want you to see something. Let's say I do the following. Whoops. Okay. Let me just create this, and then I'll fix it as I go. So what if I go halfway around the circle? What if I create something, and to remind you, this is called a semicircle, right? It's half of a circle. What would be the degree measure of this thing that I created? So in other words, if I create a full circle, that's 360 degrees, right? Full circle is 360. So what's half of that? Well, 360 divided by 2, this happens to be 180 degrees. And I want you to notice something. No, there we go. You see this straight line? What do we know about straight lines? What's their angle measure? Well, the angle measure of a straight line is 180 degrees. So in this lesson, we're going to kind of talk about how the angle measures that are inside of circles actually relate to what we call the measure of an arc. But before we get there, let's just recap a couple of things about arcs. So an arc is a piece of the circumference, right? So the circumference is kind of like the perimeter of the entire circle, and an arc is a piece of that. So for example, let me just highlight something. Let's use purple for today. If I highlight B to C, that piece of the circle is called an arc. Now we can be more specific with arcs, right? Arcs can be either minor or major. So a minor arc is an arc whose measure is less than 180 degrees. So remember, measure talks about degree measure. So for example, if I said, what's the measure? Oh, I'm lagging. Oops, that's weird. What's the degree measure of a full circle? Whoa. I don't know why I'm lagging. Anyways, what's the degree measure of a full circle? That's 360 degrees. But if I did, let's say I did this piece, is that piece less than half of the circle? Yes, so it must be less than 180 degrees. Major arc is the opposite. It's greater than 180, so meaning it's kind of like completing more than half the circle. So for example, we can do C to D, and then let's say we continued and went all the way to B. That would be considered a major arc because it's greater than going halfway around the circle. Okay. So, a couple things. I'm going to give you some definitions. So remember, you should be taking notes. This is where like the real meat of the lesson is. So make sure you're writing all of this down, ladies and gents. All right. So, a central angle of circles. A central angle of a circle is any angle that has a center of the circle as its vertex, right? That's the point where the two rays meet when you make an angle. We typically designate the angle by using 2 points that lie in a circle and the center of the circle. So for example, you ready for this? This is what it looks like. Here's a point that's on the circle. I'll call it D for D'Souza. Here's another point that's on the circle. Let's call it F for Miss Fu. This angle that I just highlighted in yellow, so DOF, is considered a central angle because it's created by using the center of the circle and 2 points that are on the circle, meaning on the circle is on the circumference. Okay. Now, let's go a little bit further. Okay, so that's what it looks like. If I asked you, what's the measure of the arc? So for example, if I said, and this is how you will see it, what is the measure of arc DF? So DF. Come on. What is the measure of arc DF? So remember, that arc is this one. I'll highlight it for you. Right? It's going to equal to the angle measurement of our central angle. So let's pretend, and again, we'll do 2 examples. Let's pretend that this is, let's say, 40 degrees. Boop. Then the measure of the arc is going to be considered 40 degrees, like this. So central angles look like this, where the vertex is the center of the circle. And if I were to ask you what is the measure of the arc or the intercepted arc, so for example, you see how the rays of these angles intersect the circle? Well, the intersected arc is this green highlighted piece. So if I tell you that the angle is 40 degrees, then the measure of the arc is 40 degrees as well. Okay, so it matches. There's nothing else that's different. So let's do 2 examples. So this first example is us figuring out how do we identify what a central angle is. So again, I left the important information up on top, and let me read the question for us. Circle B is shown below with various points located on it. Right? We have D, A, C, E, and the center of our circle is B. Which angle below is a central angle of the circle? So, Dora the Explorer style, try to look at the information on top. You actually don't need this right now. Okay, so you just need this piece of information. I'll give you a couple of seconds, or rather pause the video and try to figure out yourself which one of these angles would be the central angle. All right, so let's check it out. The correct answer is 3. So let me explain why it's 3. A central angle, its vertex has to be the center of the circle. Okay, when you look at angles and you write them out like this, so DAE, CEB, the vertex is always the middle letter, right? So A, E, C, and B, right? So if the vertex has to be, if the central angle has the vertex that's the center of the circle, and the center of our circle is B, this is the only one that has that. I'm going to outline it for you. CBA, so C to B to A looks like this. And do you see how it's an angle where the vertex is in the center? That's it. All right, let's do now like a more mathy one, right? So in the diagram below, circle D is shown to the right, and the measure of ADB is equal to 112 degrees. What is the measure of arc AB? Remember, you always assume it's the minor arc unless they are more specific. And then they're going to ask, okay, well now what's the measure of ACB? Okay, now ACB, remember, that's the major arc because it's telling you 3 points. It's telling you literally how to travel. So pause the video, try to figure it out yourself. All right, so central angles equal the measure of its intercepted arc. So this ADB is a central angle. And do you see from here to here, this is the intercepted arc. So the measure of AB has to be equal to the angle equal to the central angle. Has to be the same. So that's 112 degrees. All right. Now it's asking, well, I don't want to know that. I want to know this. So A to C to B. It's a little problem solving, right? A full circle is 360 degrees, right? So a full circle is 360 degrees. Whoops. Doing on my calculator just to make sure, right? But this part of the circle is 112, so I want to know what's remaining. So I can subtract 112, and then my calculator says that the measure of ACB, I'll even write it out, the measure of ACB, I don't know why my stuff is lagging today. The measure of ACB is 248 degrees. Okay. Now, if you think about it, the red piece, if you look at our circle, the red piece is 248, the purple piece is 112 degrees. Together, if you add that all up, that's the complete circle. That's 360 degrees. All right, in summary, okay, we talked a lot. And there's two main things I want you to take away. A central angle of a circle is any angle that has the center of the circle as its vertex. We typically designate the angle by using the 2 points that lie on the circle and the circle center. So for example, in the example below, ACB is a central angle because angle C is the center of the circle. Now, if I ask you what the measure of the intercepted arc is, so remember the intercepted arc is this piece over here, right? The measure of the arc is equal to the measure of the intercepted angle. So since angle C is a central angle, and we're saying that it's x degrees, it could be any number, right? It could be 180, it could be 20, it could be 19, it could be 15.4, it could be 359.99, it doesn't really matter. If it is a central angle, then the arc equals the angle. So then the arc of AB, or rather the measure of arc AB, is equal to whatever that number is. Okay, so make sure you took your notes. We're gonna have another video with more practice problems, specifically more things that you'll see like on the regions. Again, please leave comments on Google Classroom. If you have questions, email me, come to office hours. I'll be hanging out in Zoom. Again, I hope you're all doing well. And I'll talk to you all soon. Have a great rest of your day.